This is Mathematics Entrance Examination of 2022. It's part 4. In this video, I will show you the solutions of the portions of grade 12. If you want, you can find the solutions of grade 9, grade 10, and grade 11 in part 1, 2, and 3 respectively. So here I'm going to show you the solutions of the portions of grade 12. So stay with me. I'm using the booklet code 058. So according to the order of this booklet code, the first question that we can get from grade 12 is number 7. Here in number 7, we have a certain quadratic function. If f of x is equals to x squared plus px plus 1, where f of 0 and f of 1 have opposite sign, so that f has roots in the interval 0 to 1, then which one of the following number is possible value of p? So based on this information, we will try to find the possible value of p. So let us put the information first. We know that f of 0 and f of 1 have opposite sign. It's given. So what is f of 0? Substitute 0 in the function. 0 squared plus p times 0 plus 1. Therefore, our f of 0 becomes 1, which is greater than 0, which is positive number. Let us evaluate the function at 1. F of 1 is equals to 1 squared plus p times 1 plus 1. So f of 1 is p times 1 is p. 1 squared plus 1 is 2. Therefore, f of 1 is p plus 2. So definitely f of 0 is positive. F of 1 must be negative because f of 0 and f of 1 have opposite sign. So if p of if p plus 2 is less than 0, if p plus 2 is less than 0, the value of p must be less than negative 2. So any values less than negative 2 will satisfy this condition. So from the given alternatives, the value of p, which is less than minus 2, is negative 3. So our answer is A. Which one of the following is the derivative of f of x is equals to tan x plus 3 to the power of x? It's about the derivative of the combination of trigonometry with exponential. Our function f of x is tan x plus 3 to the power of x. So the derivative of this function is tan x plus 3 to the power of x derivative. So using the derivative for combination of function, we can take separately tan x derivative plus 3 to the power of x derivative. But tan derivative is sine x over cos x derivative. So you can apply the quotient rule for derivative. So using quotient rule for derivative, tan x derivative means sec square x plus 3 to the power of x derivative means 3 to the power of x ln 3. Because here, if you want to know a the power of x derivative, a the power of x derivative is a the power of x times ln a. So you can apply this rule for the derivative of exponential with some base 3. So this will be our answer for this problem. Which of the following is true about arithmetic mean of a given data? We know the arithmetic mean. It's an average value of a certain data. So let us see which of these statements are true. So the arithmetic mean is affected by extreme values. Yes, the arithmetic means can be affected by the extreme values because it is the sum of the data set over the total number of the data. Therefore, it is affected by the extreme values. So A can be a true statement. Let's see for the rest of the choices. There can be two means for a given data. a certain data will have only one arithmetic mean, so B is false. It can also be used for qualitative data. This is also false. We use arithmetic mean for quantitative data. The last one, it can be obtained even in the absence of some of the values in the data. This is false. We cannot obtain the arithmetic mean in the absence of some of the data. So we need to have all the data set in the data to calculate the arithmetic mean. Therefore, the true statement is A. The next one is the integral of a certain expression. So let us see the integral of the given problem. So the integral of 1 over radical x minus e to the power of minus 3x plus 5 over x squared is the integral of this one can be written as the integral of 1 over radical x dx minus the integral of e to the power of minus 3x dx. You can take separately 5 into the integral of 1 over x squared dx. So at the end there will be an integration constant. So 1 over radical x means 1 over radical x means x to the power of minus 1 over 2 minus the integral of e to the power of minus 3x is e to the power of minus 3x over minus 3 plus 5 into the integral of 1 over x squared means x to the power of minus 2 dx. Now it's very simple. At the end there will be an integration constant plus c. So the x to the power of minus 1 over 2 means x to the power of minus 1 over 2 plus 1 over minus 1 over 2 plus 1 minus this minus by minus it becomes plus e to the power of minus 3x over 3 plus 5 into 5 times x to the power of minus 2. The integral of this one is x to the power of minus 2 plus 1 over minus 2 plus 1 plus some integration constant. So this is here minus 1 over 2 plus 1 is 1 over 2. The reciprocal of 1 over 2 is 2. 2 times x to the power of positive 1 over 2 because minus 1 over 2 plus 1 is 1 over 2 plus e to the power of minus 3x over 3. Here minus 2 plus 1 is minus 1. Therefore it becomes minus 5 times x to the power of minus 1 plus integration constant. Therefore this can be written as 2 radical x plus e to the power of minus 3x over 3 minus 5 over x. X to the power of minus 1 is 1 over x. Therefore we can write like this. So this is exactly the integral of the given expression. So our answer will be this one. Let f be a continuous function on a closed interval ab, then which of the following is not true? So the integral from a to b of f is the negative of b to a of f. So this is true when we interchange the limit of integration. When we interchange these limits of integration, the sign of the integral should be changed. So this is one of the property of definite integral. So we need to remember all the properties of definite integral to determine which of these statements are true. So the b case, the integral from b to a of a certain constant k times f is exactly the same as k times the integral. So always the constants can be taken out from the integral. So this constant can be taken out. Therefore, this is another property of definite integral. So b is true. The c case, the integral from a to b of the function f is the same as a to c plus, here it should be plus c to b of the function f for any c in ab. So this statement becomes false due to this minus sign, so it should be plus to be true. And the last case, the integral from c to c, the integral from a number to itself is always 0. So this is also true. So the false statement about the function f, the integrability of the function f is c. What is the value of the definite integral x times e the power of x? Here we do have a definite integral which can be solved by one of the techniques of integration. So this integral requires the techniques of integration by part. So the integral from 0 up to 1 of x e the power of x dx is how much? So apply integration by part. Just to remind you the formula for integration by part, u dv is equals to uv minus v du. This is the formula that we use to solve integrals that requires integration by part. So now assume u is x and dv is e the power of x dx. So if u is x, taking the derivative both sides with respect to x, du and dx are the same, and v will be e the power of x. The derivative of e the power of x is itself. So apply this rule. The integral of x e the power of x dx is equals to, this is u, this is dv. So the result will be uv x times e the power of x times e the power of x minus v du. V du is dx. So this integral is x e the power of x minus e the power of x. There is always a certain integration constant, but in the case of definite integral, that constant will not have a meaning. So the integral from 0 up to 1 of x e the power of x dx is the same as x e the power of x minus e the power of x. We substitute 0 and 1 and take the difference. So take x is equals to 1 first. So substitute 1 in place of x. 1 times e the power of 1 minus e the power of 1 minus, now substitute 0. 0 times e the power of 0 minus e the power of 0. So this result is 0. So 0 minus 1 is the power of 0 is 1, and this one is 0. So this result is 0 minus 0 plus 1. The result is 1. So the answer for this is C. If limit of f of x is equals to f of x as x approaches to 2 is 6, if the limit of g as x approaches to 2 is minus 9, so what will be the limit of this expression? So it's very simple. Let us apply the properties of limit. Okay, so the limit of f minus g over the limit of f minus g over twice of f minus 7 at x for x approaching to 2 is exactly the same as the limit of f of x as x approaches to 2 minus the limit of g of x as x approaches to 2. Apply the rules of limit over 2 times the limit of f of x as x approaches to 2 minus 7. So let us substitute the values. The limit of this f is 6 minus the limit of g as x approaches to 2 is minus 9 over 2 times 6 minus 7. This is 6 plus 9 over 12 minus 7, 15 over 5. The result is 3. Therefore, the limit of the given expression is 3. Let f and g be two functions. Which of the following statement is true about f or g? The line y is equals to 0 is tangent to the line of f of x is equals to absolute value of x at x is equals to 0. Basically, the graph of f of x is equals to absolute value of x is a graph having a sharp corner at the origin. Therefore, y is equals to 0 cannot be a tangent line. And it's not differentiable even at x is equals to 0. A is false. Let's check for the rest. If f is differentiable at a, then it is continuous at a. This is always true statement. This is every you can get the proof of this theorem. Just to save our time, take this thing as a general fact. Let's check for the c and d case. If f derivative at a is 0, then the tangent line to the graph of f at a comma f of a is y is equals to a. It's not y is equals to a, it's y is equals to f of a is the tangent line. Okay, so this is not true. If f and g are differentiable at a, then f over g is differentiable at a. This is not always true. It fails for some function g of x is equals to x or some function at x is equals to 0. For example, if I take g of x is equals to x, this function is continuous at x is equals to 0, but the fraction f over g will not be continuous at x is equals to 0 for some function f. Okay, so this cannot be true. So the answer for this is B. What is the value of a for which the function defined by f of x is equals to x plus 3 and x squared minus 2x plus 3 for different x values? So here we are asking the value of a for which this function becomes continuous at x is equals to 1. Okay, this is at x is equals to 1. So let us see what the continuous function is mean. A function f is said to be continuous if it satisfies the condition f of x is equals the limit of f of x as x approaches to a from the right and the limit of f of x as x approaches to a from the left must be the same as the functional value at a. So this is the condition for a function to be continuous at a certain point a. So having this in our mind, let us try to find the value of a in which this function becomes continuous at x is equals to 1. So the limit of f of x as x approaches to 1 from the right must be the same as the limit of a function as x approaches to 1 from the left. So this implies the limit of f of x as x approaches to 1 from the right means the limit of ax plus 3 as x approaches to 1 from the right. This must be the same as the limit of x squared minus 2x plus 3 as x approaches to 1 from the left. So in both cases, substitute x is equals to 1 in both sides. So it becomes a plus 3 is equals to 1 squared minus 2 plus 3 is 1 minus 2 plus 3 is positive 2. So a plus 3 is equals to positive 2 implies a is minus 1. The value of a should be minus 1. Therefore, this function becomes continuous at x is equals to 1 whenever the value of a is minus 1. What is the derivative of the function f of x is equals to x e to the power of x over cos x? Here we are asking the derivative of the function, a certain rational not rational, a certain function at x is equals to 0. Therefore, here we need to know how to find the derivative of a over b form. Okay, so if our function is x e to the power of x over cos x, the the rule of derivative for quotients tells us f derivative at x is equals to the derivative of the expression in the numerator first times cosine minus the x times e to the power of x times cos derivative over the square of the denominator. So this is f derivative, but x times e to the power of x by itself requires another rule. This is product rule for derivative. So x derivative times e to the power of x plus x times e to the power of x derivative. So x derivative is 1. This is 1. 1 times e to the power of x is e to the power of x plus e to the power of x derivative is itself. So we will write as it is. So in place of this here, we will substitute e to the power of x plus x times e to the power of x. So our function becomes e to the power of x plus x times e to the power of x times cosine of x minus here we have also cos derivative. Cos derivative is minus sin x. Okay, derivative of cos is minus sin x. Therefore, in place of here cos derivative, substitute minus. So this sign becomes plus x times e to the power of x times sin x over the square of the cos value. So this is our derivative. So f derivative at 0 is the required value. So substitute x is equals to 0. So e to the power of 0 plus 0 times e to the power of 0 times cosine of 0 plus 0 times e to the power of 0 sine 0 over cos square 0. We know that this term is 0 and this thing becomes 0 times anything, but here e to the power of 0 is 1 plus 0 times cosine of 0 is 1 over cos square 0 is 1 square. So this is 1 plus 0 is 1, 1 times 1 is 1, 1 over 1 is 1. So the result, the derivative of this function at x is equals to 0 is 1. Which of the following is true about bounded function? Every bounded sequence is convergent. This is false. For example, if I take an is equals to minus 1 to the power of n, this is bounded, but it's not convergent. The limit of this function is, this sequence is not convergent. So this is wrong. Every increasing bounded sequence converges to the greatest lower bound of the sequence. This is wrong. Every bounded sequence, every increasing bounded sequence must converge to the least upper bound, not the greatest lower bound. So B is false. Every decreasing bounded sequence converges to the least upper bound of the sequence. This is also wrong. It should converge to the greatest lower bound. So C is also false. Every monotone bounded sequence is convergent. This is correct statement. Every monotonic and bounded sequence. So a sequence will be convergent if it is both monotonic and bounded. Therefore, the true statement about bounded function is D. Suppose f is twice continuously differentiable function. Suppose f is twice continuously differentiable function and the second derivative of the function at 3 is 5. If g is defined by the composition of f with 2x plus 3, if g is f of 2x plus 3, then the second derivative of g at 0 is equals to how much? So since f is twice differentiable function and 2x plus 3 is also twice differential and continuous, then the composition is also g. G is also twice continuously differentiable. Therefore, let us write the derivative of g. So derivative of g is, using the chain rule for derivative, this is the same as 2x plus 3 derivative times f derivative of 2x plus 3. So when we apply the chain rule, we will get this one, but 2x plus 3 derivative is 2 times f derivative at 2x plus 3. This is the first derivative for g. Now the second derivative of the function is, again we apply the chain rule for derivative, is 2 times derivative of the inner function times the derivative of the second derivative of f at 2x plus 3. So again the derivative of this one is 2, so 2 times 4, 2 times 2, which is 4, times f derivative is for second derivative at 2x plus 3. So 2 times 2 is 4, 4 times second derivative of f at 2x plus 3 is the same as the second derivative of g at x. Now the question is, what is the second derivative of g at 0? So the second derivative of g at 0 is 4 times the second derivative of, put 0 here, 2 times 0 is 0, plus 3, 3. Therefore, the second derivative of g at 0 is 4 times the second derivative of f at 3, which is 4 times, we know this value, it is already given, it's 5, therefore 4 times 5 is 20. So the second derivative of g at 0 is 20. If f and g are continuous function at a, then which of the following functions may not be continuous at a? So we need to remember only the principles of continuity of a function for 2 or more functions. So if f and g are continuous at a, the linear combination is also continuous at a, therefore this is continuous. If f and g are continuous, their product is also continuous. Here again we do have f minus 2g, it's a linear combination of the two functions. So since f and g are continuous, their linear combination is also continuous, but this is not always true. This may not be continuous for some function g of x is equals to, for example, if you take g of x is equals to x, and you can take some arbitrary function for f in which both functions are continuous at x is equals to 0, but their ratio may not be continuous. Therefore, this is not always true. Therefore, the wrong statement about f and g is C. Let f be continuous function on a certain real number. F is continuous on a certain real number, and C be a number in the domain of f. Which one of the following must be true about the function? So let's see which of these choices are true about the function. A must true statement. An absolute maximum value of f which is attained at a critical number is also a local maximum value of f. Definitely this is a true statement. If the absolute maximum value, if we have the absolute maximum value of f at a certain critical number, definitely that absolute maximum can also be a local maximum value of f. The converse may not be true, but this is a must true statement. So the rest should be false. Actually, a must be a must true statement. For example, if we take the B case, if the second derivative at c is 0, then c comma f of c is an inflection point of f. This need not be a true statement. If, for example, take f of x is equals to x. Definitely the second derivative of this function is 0, but this function do not have an inflection point. It's a straight line passing through the origin, so such function will not have an inflection point. So this cannot be a true statement for some function. So B is false. If f of c is local minimum value of f, then f derivative at c is equals to 0. This may or may not. If f of c is local minimum value of f, the derivative of c may be 0. The derivative of c may not, the derivative at c may not exist. Okay, so this is not a must statement. If c is a critical point of f, then f of c is the extreme value of f. This is also wrong, because if c is a critical point of f, the condition is f derivative at c must be 0, or f derivative at c must be non-existent. So the answer for this question is A. What is the seventh term of an arithmetic sequence whose third term is -4 and common difference is 5? So it's about an arithmetic sequence. Here we need to know the properties of an arithmetic sequence. A sequence is said to be an arithmetic sequence if the difference between the consecutive terms is a constant. So we need to have also the formula for an arithmetic, the nth terms of an arithmetic sequence. So the nth term of an arithmetic sequence is given by this formula, a1 plus n minus 1 times d, where d is the common difference, a1 is the first term, an is the nth term of an arithmetic sequence. So in this case, the third term is -4. So the third term is -4, meaning that based on this formula, the third term is a1 plus 2d. So we do have one thing, but the common difference is given. Therefore, the common difference is given. -4 is equals to a1 plus 2 times the common difference. This is 10. So -4 is equals to a1 plus 10. This implies the first term is -14. The question is, what is the seventh term? We are asking the seventh term of an arithmetic sequence. So the seventh term is the first term plus 6 times d. So the first term is -14 plus 6 times the common difference is 5. So this is 30. So -40 plus 30, the result is positive 16. Therefore, the answer for this is positive 16. If the perimeter of a rectangle is 120 meters, what are the lengths L and the width W of a rectangle that maximizes the area? So here we have a rectangle with perimeter 120 meters. So normally the perimeter of a rectangle can be defined as twice the sum of the lengths and the width. So the perimeter is 120, therefore 2 times L plus W is 120 meters. So this implies dividing both sides by 2. We will get the length plus the width of a rectangle is 60 meters. So we can write the width in terms of the length. So the width of this rectangle becomes 60 minus L. Now let's go back to the required thing. We are asking the lengths and the widths in which the area of the rectangle becomes maximum. So area of a rectangle is defined as length times width. So we can write the area in terms of L. So area as a function of L is equals to L times W is 60 minus L. You can substitute here In place of w, you can substitute 60 minus L. Therefore, area as a function of L can be expressed as 60 minus L squared. 60L minus L squared. So we need to apply the concept of derivative to get the required dimension. So calculate the derivative of area with respect to length. That means the derivative becomes 60 minus 2L. Now to obtain the critical point, calculate the derivative of the area for 0. So this means 60 minus 2L is equals to 0. This implies L is 30. Solve for this for 0. Then L value becomes 30. Therefore, if L is 30, W becomes 60 minus L. W is also 30. So for these widths and lengths and widths, the area of this rectangle becomes maximum. Therefore, the answer for this problem is B. The sum of the first 8 terms of a geometric sequence with first term 0.3 and common ratio 1/10. Here we have a geometric sequence with first term, with the first term of the geometric sequence denoted by G1 is 0.3, or you can write 3/10. And the other information about this geometric sequence is the common ratio of the geometric sequence is 1/10. Basically, a sequence is said to be geometric if the ratio between the consecutive terms is constant. That constant is called common ratio. So given this first term and common ratio for this given, we are asked to calculate the sum of the first 8 terms of a geometric sequence. So here we need to have the formula for the sum of a geometric sequence. Here is the formula. The sum of the first n terms of a geometric sequence is given by G1 into 1 minus r to the power of n over 1 minus r. So put n here. N is equals to 8. Therefore, the sum of the first 8 terms is equals to the first term G1 is already known, which is 3/10. 3/10 into 1 minus r is 1/10. 1/10 the power of 8 over 1 minus r. Okay, so this 1 minus 1/10 is 9/10. So the result is 3/10 into 1 minus 1/10 the power of 8 over 9/10. So let us rewrite this one. So this implies this S8 is 3/10 times 10/9 times 1 minus 1/10 the power of 8. So this can be eliminated by 3, 1 by 3, 3. So this becomes 1/3 into crisscross this one, 10 the power of 8 minus 1 over 10 the power of 8. So this is the value of the sum of the first 8 terms of a geometric sequence. So from the given alternative, the answer will be B. Suppose f is a continuous function on an interval AB and differentiable on an open interval AB with the property f of A is equals to f of B. This is about the Rolle's theorem. Okay, so this theorem is exactly Rolle's theorem. Rolle's theorem says that for any continuous function on a certain closed interval AB and differentiable on an open interval AB with the property having the same value at the endpoints, then the graph will have a horizontal tangent line. Okay, in the Rolle's theorem, the graph will have a horizontal tangent line at c, f of c for c in AB. This is a must-true statement about the Rolle's theorem. The function has a 0 in AB, may or may not have. Okay, this is not a must-true. The function has a minimum. It may have minimum or maximum. Here, the same thing, minimum or maximum. So these three things are not a must-true statement for regarding the Rolle's theorem. Therefore, our answer is D. The integral of a certain rational expression. This rational expression is given, and we are asked the integral of this expression. So usually whenever we have a rational expression with degree of numerator greater than the degree of denominator, here the degree of numerator is 3, the degree of denominator is 2. So in this case, the better way is we need to write this in decomposition form. So using polynomial division, we can see that x cubed plus x squared minus x over x squared plus x minus 2. This can be written as using polynomial division. This can be written as x plus x over x squared plus x minus 2. So here I used polynomial division, so you can refer back what polynomial division is mean from grade 10. So this can be written in this way. Again, we need to write this part using decomposition into partial fraction. We know that x over x squared plus x minus 2 can be written as some constant a over x plus 2 plus another constant b over x minus 2, because the factorized form of x squared plus x minus 2 is x plus 2 times x minus 1. Okay, this is here, it should be x minus 1. So using decomposition into partial fraction, you can determine the value of a and b here. Crisscross it and equate with this expression. So when you do this simple crisscross, you can get the value of a is 2 over 3 and b is 1 over 3. Therefore we can write x cubed plus x squared minus x over x squared plus x minus 2 as x plus 2 over 3 times 1 over x plus 2 plus 1 over 3 times 1 over x minus 1. You see, this rational expression can be purely decomposed in this manner. Therefore, if you want to do the integral of this one, just you can do like this. Take both sides by the integral with respect to x, so that it becomes the integral of x dx plus the constant 2 over 3 1 over x plus 2 dx plus 1 over 3 the integral of 1 over x minus 1 dx plus some integration constant c. C is an integration constant. So the integral of x is x squared over 2. This is x squared over 2 plus 2 over 3 times the integral of 1 over x plus 2 is ln of x plus 2. The integral of 1 over x minus 1 is ln of the absolute value of x minus 1 plus integration constant c. Here, this problem will be simple only if we are able to decompose the given rational expression in this manner first. So this problem really requires polynomial division, and decomposition into partial fractions. So it requires two different concepts so that you can easily obtain the answer. So based on this result, our answer will be plus plus here. Okay, addition is commutative. You can interchange the place of this one and this. There is no problem. So this is all about the portions of grade 12. If you are really happy with my lesson, please don't forget to like, subscribe, and share. Thank you for listening.